Welcome back with another lecture from organic chemistry. In this lecture, I'm going to go through alkenes and alkynes. The first thing that I have to say, whenever we're talking about alkane are saturated compound, and the formula for them, it will be CnH2n plus 2. Now, when you switch to alkenes, you will get an unsaturated compound. You can have more than actually one double bond, and it depends to how many bonds or rings that you are dealing with. You will subtract 2 hydrogen from alkane formula. Okay, 2 hydrogen atoms. Number of pi bonds or rings that they are attached to the system, they actually determine the degree of unsaturation. So, for example, with this molecule is saturated, and there is no degree of unsaturation here technically, or you can say it's 0. But the degree of unsaturation for alkene, the molecule on the right side, I see 1 pi bond, so I'm going to say it's going to be 1. Let's put the formula side by side. Maybe that's going to help us better to understand, what we are dealing with. So we said alkane, the formula for it is going to be CnH2n plus 2, 2n plus 2. Okay, let's pick n equal 3, and that's going to give us C3H. It will be 8. Okay, well, alkene, it will be CnH2n. Okay, and 2 is gone, so that 2 we don't have it anymore. Okay. And we are supposed to say here we're supposed to say 2 and then subtract 2 from it, so that 2 is gone. We don't have it anymore. Okay, and if n is equal to 3, okay, the formula is going to be C3H6 time. Okay, and we said for alkane we can have cyclic compound, and one example is going to be this. This is cyclohexane. Okay, so it will be cyclohexane. Okay, An represent saturated compound. Well, on the right side, okay, you can have same structure, but with 1 double bond, and feel free to put the double bond wherever you want. And this one, it will be cyclohexene. Okay, hexene. So now I'm using En to say that I'm dealing with unsaturated compound. So whenever we're talking about alkene, we replace An. We replace An by En. Okay. In the last chapter, when I was talking about cyclic compounds, I said that because we are dealing with a cyclic compound, there will be no rotation inside the ring. And because the system will be in fixed position, you might get some new isomers that we call them cis or trans. And the way actually we figure cis is trans, and we said let's see in which direction they are actually pointing. If they are pointing same direction, we call them cis. If they are opposite, it will be trans. So from now, I'm going to say if they are both substituents are pointing up, or down. In that case, I'm going to say I'm dealing with cis. Otherwise, okay, if I get up, down, okay, or down, up, that one it will be trans. Okay, I'm going to write it here. This one it will give me trans. Okay. The example that we have OH. Okay, that is 4 carbons far from the methyl. Let's say OH is pointing up and it's the same direction as the methyl. Why? Because the wedge is showing me that this OH technically is pointing to us. So I'm going to say this one, it will be up, and the methyl also up. And there are 4 carbons far from each other. Let's put the OH here. Okay, 4 carbons far from it. We're going to have the methyl, and methyl, we're going to put it here. Okay, OH is in axial position, but it's pointing up. Methyl is in equatorial, and it still is pointing up. And the one that you do care about it is this. Okay, that both of them are pointing up, so that you're going to call this one, you're going to call it cis. Okay, so let's start with this structure, and we have OH. Okay, and we're going to have H there. Okay, this one's going to be H. And methyl, it will be there. If we get ring flip, okay, the axial, it will turn to equatorial, and the equatorial, it will turn to axial. But up, stay up, and down, stay down. Okay, don't mess with technically their direction. Okay, so whenever we do ring flip, as you see, this part of the molecule, it will go down, and the OH right now is in axial position. It will be in equatorial position, and it will be here. This is the equatorial position. So you will have the OH here, and then you will have hydrogen. Okay, and the methyl used to be equatorial. Now it will be in an axial position, and it's 4 carbons far from OH. So I'm going to put it here. Okay, I'm going to put it there. Okay, this is going to be CH3, and here I will have hydrogen. Let's label the methyl. Okay, methyl used to be equatorial, pointing up. OH used to be axial, pointing up. Okay, and that's the reason we call them cis. Now, OH is in equatorial, it is pointing up. Methyl is in axial, and still is pointing up. So now check this. Okay, check this. That methyl is pointing up. Methyl here still is pointing up. How about the OH? OH was pointing up, and here you go, still is pointing up. But how about their, like, whether they are axial or equatorial? I'm gonna highlight just one of them. Okay, methyl used to be equatorial, now is in axial position. Okay, and if you go after OH used to be axial, now is in equatorial position. Okay, so that's going to be another actually cis. Okay, another cis conformation. Okay, so you can put the OH in equatorial position, but still you will get cis. Okay, I'm going to show you. I'm going to put the OH here. Okay, that's the equatorial. It's pointing down, equatorial, but it's pointing down. And I'm going to put the methyl here. Okay, axial, but it's pointing down, and the methyl's there. Okay, and that still is going to be cis conformation. Okay, so both of them are cis conformation. Okay, in this case, OH is pointing down, well, the methyl is pointing up. So let's put the OH here. That means we're going to have hydrogen here, and OH is in equatorial, but it's pointing down. And the methyl, it will be 4 carbon far from it, and I want the methyl to be pointing up, so I'm going to put the methyl here. Methyl, it will be in equatorial, and it will be pointing up, and here you have hydrogen there. Okay, so let's put the OH here and do ring flip and see what will happen. Okay, OH from axial, from equatorial, it will go to axial. Okay, this is the axial position. Okay, and as you see, OH is in equatorial, but it's pointing down. Now OH is in axial, and again it's pointing down. How about the methyl? Methyl used to be equatorial, pointing up. Now it's going to be in axial position, and this is the axial position. Okay, so I'm going to say axial, and it's pointing up. Okay, and they are opposite of each other, so this one it will be trans. Okay, and you can put the OH here, methyl there. Sorry, H here, and put the methyl there. That one also, it will give you trans geometry. Okay, so in all of them, we are dealing with the trans geometry. Now, I want to know how to name alkane, okay? Alkenes, forgive me. How to name them. Okay, again, as usual, we're gonna pick the main parent or the main chain. The main chain is the chain that has a double bond in it, and it has the maximum number of carbon there. Okay, so this is gonna be the parent chain. Okay, how many carbons are there? We're gonna start from the side that is closer to the double bond. 1, 2, 3, 4, 5. So I have 5 carbons. So I'm gonna say I'm dealing with I'm supposed to say pentane. I go pentene. Okay, pentene. Okay, next, where is the double bond? It's started from the second carbon. So you need to show position of the double bond. You're going to say the double bond started from carbon number 2. It will be pentene. Okay, do I have substituent? Yes, I have substituent, and it's on the 4th carbon. So you're going to say, okay, I have carbon, I have methyl on the 4th carbon. So I say methyl. YYL, because I want to say it's attached to something. And then we say pentene. Okay, so it will be 4-methyl pentene. Okay. So as you see, the AN was replaced by EN. Okay. If you take the saturated compound of C2H6, the name for it, it will be ethane. Okay, ethane. But if you make it unsaturated, the name it will be in ethene or ethylene. Okay, and that's a common name. That's kind of like common name for ethene. And the next one is propene or propylene. Okay, again, those are adopted names, and both of them are correct. Okay, I want to practice some example about how to name alkene. Okay, how to name them, and we'll start with this. Okay, so we said first thing that we need to know. Okay, where is the position of the double bond? Okay, 1, 2, 3, 4. That's the main chain. So main chain, and carbon, the double bond started from carbon number 1. So I'm going to name it this way. I'm going to say it will be 1. Okay, okay, how many carbons I have? 4. So it will be 1 butene. Okay. And sometime also they say right number of carbons that you are dealing with. I have 4 carbon, so I go but, and then you show position of the double bond. Where is the double bond? It's on the first carbon. So you say 1 En. Okay. You can do it that way. Okay. That's another way to write it. Okay. But for now, let's stick with this one. Okay. 1 butene. Okay. And how about the second one? This is the main one. And we have 1, 2, 3, 4, 5, 6. So we have 6 carbon, and double bond started from second carbon. So I'm going to say this is going to be 2. Okay. Hexene. Okay. 2. Okay. So 2 hexene, or again, you can say hex and 2 En. Okay, 2 En. Another one. Okay, should I choose this one as a main, main chain or the parent chain? Okay, answer is going to be no. Why? This one is not correct because it's not including the double bond. So that's not going to be correct. Okay, I'm going to erase this one, and I will say the parent will be this. Okay, why not to the right side? Because you will have more carbon on the left side. So you say 1, 2, 3, 4, 5, 6. Okay, let's name this until now. What do we have? We have 6 carbon, and there's a double bond. Okay, so I'm going to say on the first carbon, okay, I have a double bond, so it will be hexene. Okay, hexene. Okay, do we have substituent? Yes, this is our substituent. And what's the name for it? It's going to be a propyl. Okay, where is it? It's sitting on the second carbon. So I'm going to say on the second carbon, here, on the second carbon, I have propyl. Okay, on the second carbon, I have a propyl substituent. Okay, and then I will put dash line, and then I attach this one to it. So the correct name, it will be 2-propyl 1-hexene. Okay, 1-hexene. Some of you might ask this: do I need to write 1? Okay, no, honestly, it's fine if you know the carbon, like the first carbon is actually the double bond started with the first carbon, then it's fine. Okay, but we want to show the position of the double bond, and even if it's 1, we try to show it. So always we put number there because it's going to be easier for the reader to understand position of the double bond. Okay, more example. What do we have here? Okay, this is going to be our main chain. Okay, and we're going to say 1, 2, 3, 4, okay, 5. Okay, why don't you put the 1 there? So if you see 1, 2, 3, 4, 5, as you see the double bond, okay, here start with 2, there start with 3. So the correct name for it is going to be, the correct locator for double bond should be 2. Okay, so I have methyl group sitting in the 4th carbon. So I'm going to say 4-methyl, 4-methyl, and then, okay, I'm going to say on the second carbon, I have double bond. Okay, so this is the position of the double bond. Double bond. Okay. And then you say name of the main chain. It has 5 carbons. So you say pen, and then you say pentene. Okay, pentene. Okay, another example. Okay, this is going to be your main chain. Okay, and you start labeling from the left side because carbon double bond, it will have a smaller number. So I go 1, 2, 3, 4, 5, 6, 7, and 8. Okay, this is methyl, and that one is ethyl. Okay, the priority here goes with ethyl. So ethyl should come first, and then the methyl. Okay, so I'm going to say on the 6th carbon, I have ethyl dash. On the 3rd carbon, I have methyl dash, and on the 3rd carbon, I have double bond. And how many carbons total we have? We have 8 of them. So I say OCT stand for 8 carbon. And do I have double bond? Yes. And I said double bond is sitting on the 3rd carbon, so it will be En, and you put E at the end just to show that you're dealing with carbon and hydrogen. Okay. Let's go through this example. Okay, And so the question is, should we choose this one? Should we choose this one as a main chain, or we should go this way? Okay, this is going to be the correct one. Why? Because it's including the double bond, and also it has more carbon. Okay, if you go in this direction, you will have one carbon here, just one carbon after double bond. But if you move in this direction, you will have two carbons there. Okay, so this is going to be the correct one, and it's showing you that 1, 2, 3 on the third carbon you have a double bond and also methyl group, and then you say 4, 5, 6, 7. So the correct name for this one, it will be this. Okay, it will be 3 methyl, and then you see dash on the third carbon. We have a double bond, and it will be heptene. Okay, heptene. Okay, how about next one? Next one, this is going to be the main chain. Okay, you have a chloro versus bromo. Priority goes with bromo, and remember you have a double bond and it's on the first carbon. So I'm going to say on the fifth carbon I have a bromo. Okay, you might say, why did I start from from the right side? The reason I started from the right side, because I want to give the double bond the smallest number. So this is going to be 5 bromo, and then I say 4 chloro. Okay, 4 chloro, and then I say 1, and this is going to be heptene. Okay, heptene. Okay, and so 4 bromo, 5 bromo, 4 chloro, 1 heptene, and that's going to be the correct name for it.